Welcome back, my beloved chem students from Allen High School. We are both AP and IB chemistry combined here, and we are working our second AP question on equilibrium. Now, this time you want to pay close attention to states. We have a solid decomposing to form two gases. We're given a delta H of plus 93 kilojoules. That means that heat is a reactant, and another word of saying that is it's an endothermic reaction. Now, our temperature, we may or may not need to know the exact temperature, but it's always a good idea to underline what you have. We're talking about 25 degrees Celsius. We have some solid remaining. Now, that's critical when you have solid and in equilibrium, because as long as there is some solid, we don't care how much. We have enough to ensure that we have exactly the amount or the maximum amount of gas that will form under these conditions. Now, the question asks us, the first one says to predict and explain. So we're going to make a claim and we're going to justify that claim. We want to know what happens to the partial pressure of NH3 when we add solid NH4S. Well, our K for this reaction is the partial pressure of NH3 times my partial pressure of H2S, and solid NH4HS doesn't show up in here at all. So we're not shifting K to a new Q state at all. We stay the same. The addition of solids do not stress a system that is in equilibrium. So you will have to say that in words somehow. I'm going to let you take those notes, but our claim is that there is no effect. And how you discuss that in terms of the solid, you need to write a statement such that the addition of solid has no effect. It's not in K at all. So it doesn't stress. Okay, a couple of ways we can write that. Does not stress the system away from equilibrium. Try to find you some words there. I'd like you to find your own as well. Okay, so there's nothing to happen to get back. Okay, so now let's try the next one. Honestly, this is the second time I've made this video, because when I read the second one, it took me back. I thought, oh, do I have a typo? Because this time it says, what happens when additional solid H2S has been added? Now, if I add solid H2S under these conditions, it's hopefully clear to you that H2S prefers to be in the gaseous state at these temperatures and pressures. So the H2S solid will form gas, and what that will do is increase our partial pressure of H2S. Now, there's two ways we can do this. K, which remember was our partial pressure of NH3 times our partial pressure of H2S. What we did in our stress is we increased this value. Now, since temperature is constant, that K has to be constant. So to offset that stress, we would need to decrease our partial pressure of NH3. Now, another way of saying that is once we do that stress, we now are at a Q or non-equilibrium state that is greater than K. That means we have too much product, and so we need to consume the product and produce reactant. Let me use the word form reactant instead of produce there. Form reactant. Well, it asked us about our NH3. That's a product. If we are consuming product, that tells us that our partial pressure of NH3 needs to decrease. Now, if you need to use kind of that pencil trick to get your claim down, here's what you can use. You can't use this to justify, but it can help you make sure you predicted the right way. So there's our equilibrium. We're going to stress our equilibrium by adding H2S gas. So that was our stress. Now, to get back to equilibrium, we're going to form reactant, which actually means we would have more mass of our solid here. And we're going to consume products, which means that the partial pressure of NH3 will have decreased. All right, now the H2S, remember, if you go back to my chart, we would actually likely see a remaining or a residual increase in that. All right, so you got to justify, though, using the K's and the Q's. You can't use that little pencil trick for your justification. All right, let's now go on to C. This time it's not, notice it's not saying do they shift right, shift left. You know I hate that terminology. It's saying what is the effect on the mass? Now, if we add a solid, there is no effect. But a shift can actually increase or decrease the amount that's present. So let's evaluate what happens here. If you decrease the volume of the container, that's going to increase the partial pressures of both gases. So let's take a look at two ways we can look at that. K is equal to the partial pressure of NH3 times the partial pressure of H2S. An increase in pressure will shift to the side with the fewest moles of gas in order to reduce that pressure stress, right? If you reduce moles, you reduce pressure. And so the side that we would look at there then is this has 2 moles of gas on it. This has 0 moles of gas. So that means it's going to shift to make more reactant. And that means we will, reactant, you can get that. There we go, that's an N. That means we're actually going to increase the mass of the solid. So we can have changes happening to that solid, but the addition of the solid doesn't affect it. Now, let's look at a Q way of looking at this. If we increase both partial pressures, we're no longer at equilibrium. We're at a non-equilibrium Q state. And that Q is, in fact, greater than K. When Q is greater than K, that means my numerator is too large. And since my numerator has the product, it means I have too much product. So to get back to K, I need to consume my product and form reactant. And so we get the same conclusion. So a couple of ways you can justify that stress. All right. Now let's look at the last one. What is the effect? Again, it's asking us what is the effect on the solid if temperature is increased. Well, when you see this increase in temperature, the first phrase you want to say is, since it's endothermic. Since my reaction is endothermic. It's a key part of your justification. Since the reaction is endothermic, you can use your pencil trick to help you. You can't use it to justify, but it can help. So here's my little pencil. That represents equilibrium. I've stressed by adding what is effectively a reactant. All right. So the system is going to consume reactant and form product. So since the reaction is endothermic, requiring heat. When I give it heat, I'm going to form product and consume reactant. All right, so what will happen here is if I'm going to consume reactant, my mass of NH4HS will go down. I'll use some more of it till it reestablishes equilibrium. Just to give you a little bit more complete reaction, both my partial pressures of H2S and NH3 increase. And here's a key statement you want to know. We're not reestablishing its temperature, so we're going to reestablish a new equilibrium, or we're going to establish a new equilibrium or a new K. New equilibrium with a new K value. Okay. Now, you'll cover yourself if you always write that in a LeChatelier that's talking about temperature, since it's exothermic or since it's endothermic. You want to point that out. All right, that is the end of this one. So there's one more to watch. Until then, this is YBCT, your beloved or your best chem teacher, signing off.